So if you do a molecular count, line up all the molecules, more than 99 out of 100 are going to be water molecules. And the books tell us that water molecules don't do much. They're sort of sitting as the background carrier of the more important molecules of life, which strikes me as arrogant. How could anybody imagine that 99% of the molecules in our body don't do anything? Well, the evidence is clearly against. The water molecules are central to so many processes that go on.
Okay, you fellow water freaks and geeks, we've got a crusher of an episode for you today. This is number 425, where science meets the mystical, the fourth phase of water, with Dr. Gerald Pollack. For show notes, links, transcripts, and all the things related to this episode, please visit lukestory.com/ezwater. And before we start the engines here, I'd like to invite you to follow me on Instagram. You can find me there at Luke Story, where I post all sorts of dynamic content as well as live streams of each and every episode of this show, including the one you're about to hear. So for a real and raw behind-the-scenes view into what we do here on The Lifestylist, again, find me on Instagram at Luke Story. And for the many of you who've grown tired of social media censorship, you can join my Telegram channel at lukestory.com/Telegram. Now, be forewarned that my Telegram channel is pretty far out, being that it's the only public place where I can speak freely at this point, sadly. So enter at your own peril or glee, depending on your degree of open-mindedness and curiosity. Again, that's lukestory.com/Telegram. Okay, on to our guest. Man, I am stoked for this one. Gerald, or Jerry as we know him, Pollack, is a scientist recognized worldwide as a dynamic speaker and author whose passion lies in plumbing the depths of natural truths, just like this here podcast. Jerry received the first Emoto Prize and is a recipient of the University of Washington's highest honor, the annual Faculty Lecturer Award. He's also founding editor-in-chief of the research journal Water and the director of the Institute for Venture Science. His award-winning books include The Fourth Phase of Water, about which much of this episode is centered, and Cells, Gels, and the Engines of Life. Not to be one to rest at 82 years, he also maintains an active lab at the University of Washington in Seattle. This guy is a scientific badass and one of my favorite guests of all time. Now, as I lay out the framework for this chat, I'll provide you with a little cheat code for those of you that want to jump right to the exploration of the fourth phase of water, for which Jerry is most famous. So Hour 1 covers the history of science, or lack thereof, that led him to write his book and focus his efforts on EZ or exclusion zone water. Then in Hour 2, we get into the more rapid-fire questions outlined as follows, which were perhaps the juicier topics and the source of my focused interest and curiosity. So Hour 1 is basically a setup for Hour 2. Now that said, I of course encourage you to take it all in. Here's the basic guide to the flow of this episode for reference. Jerry shares why he is so dedicated to relentlessly working on controversial matters of science, why we understand so little about water when it covers 2/3 of our planet. We also discuss Jerry's 4 principles of water and his seminal book, The Fourth Phase of Water. And we also get into a few mysteries of water, including isolated clouds, gelatin desserts, and sandcastles. Wait for it, it's awesome. We also discuss how you can use knowledge of water to decipher the shape of the Earth. Hint, he doesn't think it's flat. He also shares his take on the debunking of some of Dr. Emoto's famous water studies, as well as recent guest Austin Veda's mind-blowing work regarding the intelligence and consciousness of water. We also dig into structured or ordered water and the various devices used for this purpose. How deuterium and deuterium-depleted water relate to the EZ phase of water. We also talk about Jerry's take on infamous healing waters found in various locations on Earth, as well as the benefits of ice baths, red light therapy, and saunas as they pertain to exclusion zone or the fourth phase of water. This is a very in-depth conversation. I've been wanting to interview Jerry for many years and was even booked to record with him a couple years back in London, at which time, unfortunately, his travel plans changed, much to my disappointment. So this is a long time in the making and one about which I am thrilled to share with you. Jerry really is a scientist in the truest sense of the word, and his intelligence and scientific rigor have helped stoke the fires of my passion to learn about water immensely. And I have a strong sense that this conversation will do the same for you. So enjoy the show, and let's welcome Gerald Pollack to the Lifestylist Podcast. So, Jerry, you seem to be quite an out-of-the-box scientist, a challenger of sorts. I'm wondering when you first realized that you wanted to sort of stretch the limits of the traditional paradigm of science.
Well, it's not that I wanted to. It's that I felt obliged to. It started when I was a graduate student at the University of Pennsylvania. And my former field was muscle contraction, the molecular mechanism of contraction. And as a graduate student, I was building some models, computer models of cardiac muscle and how the muscle worked. And I didn't quite finish. I had been a graduate student for quite a few years. My advisor enjoyed my presence, I guess, and kept me going. And finally, it was time to finish. And a Japanese guy came along who would, in theory, finish my project. And he told me, this is very uncharacteristically Japanese. Japanese tend to be modest. He said, I can't do it because the theory on which you base your model is completely wrong. I said to him, well, wait a second. What are you talking about? This theory was put forth by a Nobel laureate, and not just a Nobel laureate, but a Nobel laureate among Nobel laureates. This guy, his name was, he passed recently, Sir Andrew Huxley. And he was a member of the Huxley family, Thomas Henry Huxley, Aldous Huxley, except that he won a Nobel Prize. He was the only one of the family to have done that. And then after winning a Nobel Prize and for a different field, he came forth with a theoretical model of how muscles contract. And that model persists to this day. However, my Japanese friend told me it's impossible. He said, if it really worked the way Huxley suggested it worked, the muscle would fall apart after the first contraction. It was unstable. And it was my first inclination of the idea of stability and instability. Everything needs to be stable. Otherwise, it falls apart quickly. Well, within 5 minutes, he had me convinced that this was correct. And, then I came to realize that just because the purveyor of some mechanism happens to be a distinguished scientist, distinguished member of a distinguished family, so to speak, doesn't mean he's right. We all pee in the same pot, so to speak. We eat the same food, we may sleep on the same mattress. We all make love, and et cetera, et cetera. So a human being is fallible. And by the way, the objection that this Japanese guy came up with, his name was Iwazumi, it persists to this day. It's not the only objection to this theory. There are many other factors, which leads into a different discussion. And that's not what you asked. Just that life is difficult for people who challenge the prevailing view. Anybody else in the field, it's easier for them to follow the leader, so to speak, to follow the great Nobel laureate than to follow somebody who is challenging the view, no matter how cogent the challenge might be. It is not new. It's well known as an uphill battle. I gave you a long answer to a short question. This was my first exposure to the idea that just because something is in the textbook doesn't mean it's right.
Yeah, definitely understood. And I sense from reading your book, The Fourth Phase of Water, that your approach to science, to me, represents a more valid approach than the approach that says, we don't think that this hypothesis is possible, therefore it's not possible. Which is just
boy, have have I seen that
Yeah.
numerous times. We don't think it's possible, therefore it's not possible. And, and people in the field tend to grasp onto that. It's hard. It's hard for most people to think about a change of paradigm. They grew up with a certain way of thinking, and it's most convenient and natural to persist in thinking, oh yeah, well, what I learned in 5th grade is right. It's fact of life that one needs to contend with. So
yeah, change of mind is uncomfortable. I guess we get stuck in certain structures, and then if those structures of belief get threatened, then if one's so identified with them, then I suppose we as a person feel threatened because we're so closely identified to that belief that it's like a loss of self,
Yeah, loss of self is a good way to put it. It's a real challenge, but that is the purpose of science. After all, it's not to acknowledge that what they learned is correct. It's to find new information and new interpretations and explanations for phenomena that seem to exist. That when multiple people confirm a certain observation, the tendency is to, if it doesn't fit with the current thinking, to basically, sweep it under the carpet and let somebody else in the future deal with it, but stick doggedly to the conventional explanation. It feels comfortable for most to do that. So science involves, unfortunately, I guess, discomfort, because it involves revolutions, and revolutions are not comfortable, but that's the way we proceed. So when I look at a textbook and read something, I've gotten to the point, having done science for many years, where my first reaction is, well, if it's simple, nature operates, I think, simply. It's a principle based on so-called Occam's razor that's been around for countless generations. I think Sir William of Ockham was 14th century, I think, or something like this. And then Newton decided that his approach, Occam's approach, which was mainly a religious approach to the existence of God, you have two hypotheses. One, God exists, and the other is God doesn't exist. And the likely truth is the simpler of the two paradigms. And then Newton thought this is pretty interesting and suggested that the same principle applied to science. Science should be simple. And Einstein amended that. He said it should be simple, but as simple as possible. His view is a bit more complicated than Newton and Occam's razor. But for me, when I read something, if it has the sense of simplicity, it has a ring of truth to it. If A leads to B, which leads to C, which leads to D, it looks good. But on the other hand, most of what you read in the textbook is not like that. It's complicated. And when it's complicated, for me anyway, it raises a question of whether it's true. And those are the aspects that intrigue me and draw me into thinking about the possibility of simpler paradigms that could make more sense. So I admit to that predilection. I'm looking for simplicity. Maybe I've got a simple brain and I can't comprehend ideas that are too complicated.
As someone who spends so much time, energy, and money to be healthy, I want to keep track of what's working and what's not. That's why I'm really into this company I found called Inside Tracker. They are an ultra-personalized performance system that analyzes data from your blood, DNA, lifestyle, and fitness tracker to help you optimize your body and reach your health and wellness goals. Through their app and testing protocol, I'm able to get a clear picture of what my body looks like on the inside. And I also get a clear measure of whether my diet, supplement, and exercise choices are helping or even hurting. I did the whole Inside Tracker deal recently and was actually shocked to find that I was less than perfect in some areas. My cholesterol and B vitamins were high, for example, and a few other things that need a little tweaking. There was, of course, also some good news, as my overall health score was that of a much younger person and certainly more optimized than your average American. And that's the point. The whole goal with Inside Tracker is to be optimized, not normal. So they don't merely show you the normal biomarker zones, they show you the optimal biomarker zones and numbers that are best for your individual body. So if you want to check this out, I highly recommend you sign up for Inside Tracker now. You're going to get your testing done, the results of your biomarkers, and then some incredible lifestyle and diet recommendations from their brainiac scientists to help you improve everything you find. Just go to insidetracker.com/Luke, where you will save 25% off your entire order. That's insidetracker.com/Luke. Well, let's apply some of what you learned in terms of water. I find it fascinating that 2/3 of the earth is covered with water, and that on a molecular basis, 99% of our body is water, yet we seem to understand it so little. Over the years of the research that you focused on water, why do you think that it's so discounted in terms of humanity's desire to really understand it, specifically from a scientific point of view?
Long ago, water was a genuine area of interest in science. Now it's not, and except that there's beginning to be a resurgence. And why is it not? And I think the answer to why it's not has to do with two debacles that took place in water research. Two incidents that happened over the past, I guess now 60 or 70 years, that had a huge, huge impact on scientific discourse and society. Two ultra prominent scientists who got discounted very rapidly because they found something about water that seemed strange. And to me, these days, they don't seem strange at all because they've been essentially corroborated. And I'll just tell you briefly about the two. And if I run on too much, please stop me, because these are such interesting stories that had a really deadening impact on research in water. It sort of stopped. And the first one was a Russian guy. His name was Boris Derjaguin. And Derjaguin was the premier physical chemist in all of Russia. And he began to publish his stuff, and it was mostly in Russian, but then it was in the 1950s, I think, or early 60s, late 50s, that a lot of stuff began to be translated. And once it got translated into English, people began to be interested, especially work coming from so distinguished a scientist as Boris Derjaguin. So Derjaguin published some work about some weird properties of water. And those properties then aroused the interest of scientists. And there was something weird about it. He identified a kind of water that's different from ordinary liquid water. The vaporization temperature was higher than ordinary liquid water. The freezing temperature was lower. The density was different. A host of different properties of this kind of water differed. And when it finally got to the West after the translation, this was the time of the Cold War. We grew up learning that the Russians were idiots, and they grew up with similar propaganda about us. So there was a kind of mentality to show that the others are simply insane, And so when people started looking at Derjagin's work, the thought was, this is nonsense. This can't be. How is it possible that there's a different kind of water? It doesn't make any sense at all. And Derjagin was challenged. The Western scientists were thinking, and remember now, there's a competition between the West and the East at the time of the Cold War. And it was argued that there was some kind of contamination, that this really wasn't just water. It was some kind of contaminated water that the Russians were dealing with. And that, of course, aroused suspicion that the Russians may be dead wrong, that there is no other kind of water than this liquid. And the nails in the coffin came from, I think, from an Australian group. And what they did is they put some salt in the water. And once they put the salt in the water and made various measurements, they were able to infer that the Russians must have had salt in their water. They must have been sweating in their water during summer experiments for lack of air conditioning or something. And that was sort of, and the Russian government, what's not known widely, and what I know, having spoken to people who are intimate with this guy, with Boris Derjaguin, and I spoke to two such people, and they told me the same story, and therefore I think it's probably true, is that the Soviet government approached Derjaguin. And they said, this is really embarrassing for Russian scientists. And, if you want to keep your job and not be sent off somewhere to some work camp in Siberia, you better retract. And so he retracted. And his retraction, once he retracted, everybody thought, well, it's all over. There's no such thing as what began to be called poly water, because the water seemed to behave more like a polymer rather than a collection of individual molecules. So polywater was a debacle, and it had a serious impact on science, because the scientists then kind of thought that, oh my goodness, if the most prominent scientist in all of Russia, and there were a lot of physical chemists, the most prominent physical chemists, they had a lot of them. If he can screw up so badly by having contamination in his preparation, what about mere mortals like us? So it had a really deadening effect. And I remember when I was a graduate student, I remember a professor coming to me, and my department was actually, surprisingly, there were people interested in studying water at the time in a different way from the way we and others had studied it. And he came to me and he said, when you graduate, you can do anything you want, but don't involve yourself in the field of water. And I remember it because it was so, it's too dangerous. You dip your toe into water and your toe might freeze or something like this. So stay away from water. So that was the first debacle. And a lot of scientists stayed away from researching water because they were nervous. They wanted their careers. And then one that's maybe even more famous came along, and this was Jacques Benveniste. And perhaps you have heard the name or know about Jacques Benveniste. And Jacques was actually a friend of mine, and he passed about 15 years ago. And he found something weird. So he was an immunologist, and he was a famous immunologist, a high-level scientist with 50 people or so working in his laboratory in Paris. And he was working with a biological preparation where he would put some antibodies on a particular kind of cell. He'd expose the cells to these antibodies, and the cells would secrete, they would secrete histamine. And someone came to his lab and said, I can achieve the same result that you achieve, even if I take these antibodies and dilute them and dilute them and dilute them to the point where there's nothing left but water that had been exposed previously to the antibodies. Same result. And of course, Jacques was skeptical. He said, okay, there's a corner of my laboratory there and it's not in use. Show us. And pretty soon, all 50 people in the lab were hovering around him because he could demonstrate, indeed, that he could dilute, and the same way that homeopaths do, dilute and shake and dilute and shake and so on. And indeed, he showed the same result. And so it appeared that somehow the water molecules had information derived from the antibodies or the molecules with which the water had contact previously, implying some kind of water memory, water information. Otherwise, how could this happen? So he was impressed. They did more experiments. They submitted their results to the journal Nature, and the response from Sir John Maddox, who the late Sir John Maddox, who was the editor-in-chief of Nature, he said, and you can find this in many places on the internet. Basically, the letter said, we won't consider this even to send out for review, because you can't be right. Because if you're right, everybody else is wrong, and I, as editor, refuse to believe that everybody else is wrong. Therefore, forget it. So if you received a rejection letter like that, I'm not sure what you would do, but I would pretty much do the same thing that Jacques did. And he went to different colleagues in different countries, and he said, hey, please, could you repeat these experiments according exactly to the same protocol that we use? And sure enough, a whole bunch of people got the same result. And he put all those names on the paper and revised the paper so it included the results of those people, and sent it back again to the editor of Nature. And the response was pretty much the same. I refuse, and I don't care how many people can repeat it. It can't be right. It's impossible. It doesn't make sense, and therefore water memory is nonsense. So, feeling slightly defeated, Jacques began to notice that a lot of people in Paris, there are many homeopaths, and some of the homeopaths were thinking, well, this famous scientist is basically confirming what we do every day, confirming it in a scientific way, that if you do all these dilutions that we do every day, you really do, there is something to it. And so the pressure from Paris across the channel to London, where Nature is headquartered, became intense. And Maddox felt the pressure. And so what happened, and I remember visiting Jacques, and he said, on that phone right there, I got a call from John Maddox. He said, I'll make a deal with you. Okay, what's the deal? The deal is, I'll publish your paper next week, in next week's edition of Nature, on one condition. You allow a committee of peers to come to the laboratory, look over your shoulder, and then we'll report back to our readers and what we find. And Jacques, thinking, my goodness, thinking that this was a sincere and honest approach, said, yeah, no problem, come. So a month later, they came, and the committee of peers consisted of three people. And the three people included the editor himself, John Maddox, who was not exactly neutral. He was under pressure to relent, to change his mind. And he invited two other so-called peers. And one of them was a guy named Walter Stewart, who had been working at the National Institutes of Health. They have a Center for Scientific Integrity. They're in charge of looking for scientific fraud. So you could get an idea of what the committee of peers was after. And the third person on the committee was the epitome of the sort of scientific or other fraud. And this was the amazing Randi, otherwise known as James, real name James Randi, who had been probably the most prominent magician in the world. A magician. And a magician, this guy was famous mostly for debunking the tricks of other magicians. So the group of people coming to this French laboratory, it seemed that they had a mission, and the mission was to demonstrate that all of this is some kind of fraud. So they spent a few days there, and the first day, the experimenters did their usual, and they got the result that they published. The second day, they did the usual, and there was some coding, giving numbers to that was done by the committee, and when finally decoded, it also gave it the same result. And the third day, the experiment was actually done by Walter Stewart, who did all the dilutions himself. it turned out it didn't work. It almost worked, but there were some deviations. And so the committee went to their hotel and they conferred, and they concluded that, well, okay, when the French people do it, it, quote, works. And when we do it, it doesn't work. And they concluded, I mean, despite the fact that in the published paper, they said this does not work every time. However, it works a sufficient number of times to easily be statistically significant, more than easily. It just occasionally it doesn't work. And parenthetically, I know that sometimes it doesn't work when there's somebody in the vicinity who thinks it shouldn't work. That's a different issue that we can get to if you like. But at any rate, the group said, we do it, it doesn't work. They do it, it does work. Therefore, it's some kind of trick. And they published something that said that water memory is a delusion, a trick. And that was the end of Benveniste's career. And he died prematurely, a rather broken man. So to summarize in your original question, there were two debacles that followed. One was 30 years after the other. And these debacles meant that prominent people who found something potentially interesting about water, your career is in jeopardy if you were to find it. If you want to do something, let's say, pretty boring, dotting the I's and crossing the T's, it's okay. You can do it. But if you happen to find something that challenges the status quo, forget it, because even the most prominent of scientists their careers will be destroyed. And that had just a deadening effect. And so there is essentially no water research field. There's a group of people who do mostly computer simulations and some experiments, and they meet regularly. It's a rather limited group. And we have started something. So I each year organize the annual conference on the physics, chemistry, and biology of water. And it'll be early October in a place called Bad Soden, which is near Frankfurt, Germany. It's been a very popular meeting with increasing attendance. Of course, we've had problems because of the pandemic, but it hopefully will take place. And so we kind of like to think that this may be the beginning of a resurgence in interest in water, because there's so much that's so interesting about water.
I've actually done a number of podcasts on different elements of water around the over the years, and they've all been very well received, because I think that you and I and the people that come to your group are not alone in our fascination with something so mysterious and so ever present. You know, it's not just a random molecule that exists in few places on Earth and we want to discover where and why and how. It's everywhere. It's everything. It's the basis of all life. So to me, I think that's why my fascination continues to grow, and I appreciate the context. So I did so much digging in your book, and it's just such a treasure trove of information. But something that struck me was kind of early in the book, and there's a few mysteries of water that you sort of pose early on, and then later in the book explain them. And I think it'd be fun to go through some of them just to exemplify the strangeness of this substance and how it behaves in certain ways. You mentioned like gelatin desserts and diapers as two examples of, and sandcastles, things like that, where...
Oh, yeah. Liquid water has certain properties. You know, it flows. And I think the best example of that is, if I may deviate slightly from your question, is your body. So the kind of fourth phase water that we discovered, and I hope I have a chance to discuss it, it's gel-like. It's not a liquid. It's more like a gel. And your cells, we have evidence that your cells are filled with this kind of water, this gel-like, highly viscous water, compared to ordinary water. And the way you could demonstrate that really simply is take a knife and cut yourself. If it were liquid water, it would come pouring out as it does from a breached water pipe. But that doesn't happen. It stays in. And it stays in because the water that's in your cells is not liquid water, not for the most part. It's actually this fourth phase water, which is gel-like, and it stays there. It clings to the solids that are inside your cell. There's that inside your cells in particular, that there is water has a gel-like consistency. It's not sort of like raw egg white, is what we're talking about. The idea is 70 years old. There was a famous paper by a well-known scientist, not a paper, a book by a guy named Fry Wüstling, a German, or maybe he was Austrian. I can't recall. And essentially, this water is like a gel that can hold together because of the charges that are involved. And we'll hopefully get to talk about the charges. This is not neutral water. This is charged water that can hold things together. And one of the things it can hold together is, in the case of a sandcastle, you build a sandcastle and you wonder, the water acts as a kind of glue, right? And, liquid water there's no reason why it should act like a glue. But the water that we're talking about actually has electrical charge. And if it has electrical charge, it can induce opposite charge by the Faraday induction principle, anything that's nearby. So the sand in the sandcastle, each grain of sand nucleates the growth of this special kind of water, which then holds the particles together. So if you have wet sand, you can build a sandcastle. If you have dry sand without that water, you can't build anything. It just falls apart. So this is one example. There are so many anomalies. There's a website that lists them. There are more than like 60 or 70 or even more than that anomalies of water. The number keeps growing. And when you reach a point where you have so many anomalies, anomalies are, features that you observe, but they don't fit into the theory. So mostly they get swept under the carpet, thinking, we'll leave that for later. But when the number of anomalies grows so large, you kind of have to scratch your head and think, well, maybe there's something wrong with the basic theory, because if the theory is right on, then the opposite usually holds. The theory can explain so many things that you hadn't expected it can explain. It's a sign of a proper theory. But if you have to keep adding to it, that's not a good sign. And that's where we are with water.
There was another interesting anomaly that you alluded to in your book, and that's isolated clouds. How water vapors go up into the sky, and you could have a clear sky, and there's just an isolated packet of them just floating there in only one spot, which has always struck me as strange too. And that's
it's very strange. You have either you have an ocean or a giant lake, and look up and you see one cloud. Does that imply that the evaporation is occurring from one spot, but not the spot next to it, or what? So if you want to figure out what's going on, you must be able to explain how this can happen. Sometimes you can see, I was just flying from Europe last week, and I'm looking down, and there's so many beautiful clouds, and they're all separated from one another. And you need to be able to explain why you don't always have one over an ocean, for example, one large continuous cloud. Well, sometimes you kind of do, but that's not the general rule. So how does all this happen? And it's not only that question regarding clouds, but what keeps the cloud up in the sky? So if you were, for example, to take a ladder and climb up to the height of the cloud and climb with a pitcher of water and take the water and turn it over, you know what would happen. It would come right down like a shower on your head. But clouds don't do that. They float up there, but they both contain water. Cloud is essentially water. It may have some extraneous particles and such, but essentially it's water. And it doesn't behave like your pitcher of water. So what's going on, and how do you explain it? And a third anomaly with regard to clouds, sort of an anomaly. If you think of the cloud as water that's evaporated water that condenses. Well, if you take water and condense it, it forms a liquid. And when it rains, you might expect that somehow the cloud gets unzipped and this water comes down like a waterfall. But it doesn't come down like a waterfall. It comes down in little droplets. How do you explain that? So these are just a few of the phenomena that we witness every day, and most of us never even give a second thought to it. But it's necessary, it's obligatory to be able to explain these phenomena if you want to know about weather. And so, as you can imagine, I have been delving into that, and next book is almost ready, and it's got 4 chapters on weather, and weather is obviously water is at the center of weather. So whatever new principles that we derived as elaborated in that 4th phase book need to be applied. If they're valid, then they will play some role in weather. And the surprise is that there's no real theory of weather. If you try to understand from first principles how water evaporates, how they form clouds, why the clouds are distinct, why they float, why they sometimes dark clouds will produce rain, and other times they won't produce rain. What's the switch? How does this work? There has been no theory that I've ever seen that starts from first principles and works its way toward a hurricane, for example. I've attempted in this book to get there, and I'm just waiting. The book is essentially done. I'm waiting for my artist son, who illustrated that 4th phase book, and so many people commented on the quality of the artwork. My son is a professional artist. He's actually a sculptor, but he's busy remodeling his home, and so there's a bit of competition for his time, and I'm just waiting for him to finish the artwork. The book is essentially done, and the book actually deals with a bunch of subjects. It's not just weather; it deals with the unexpectedly central role of electrical charge in phenomena that we see every day, but we really don't understand. We may understand superficially, but once you descend down from the superficial to one step below, you run into questions you can't answer. Like, for example, gravitation. Well, everybody knows, quote unquote, that gravitation occurs because masses attract. But then you get to the next level question: why do masses attract? And then you run into throwing up your arms. Well, they just do, and that doesn't satisfy. And there are other issues in the book that I treat that relate to electrical charge. How do birds fly? So if someone asks you how birds fly, you'd probably say, well, they flap their wings. But I look out from my home, and there's an eagle's nest nearby, and I see the eagles every day pretty much flying. And occasionally they'll flap their wings, but most of the time they don't flap their wings. And they can go up and down and level for long distances without any wing flapping. The question is, well, how does this happen? And there are reflexive responses but they don't really bear a signature of truth. So I deal with that subject, and I deal with what turns the earth. Every 24 hours, Earth turns, and what's responsible for that? We never think about it, but it's a question that we need to understand. Another question is, what creates wind? We feel the wind all the time, but what's the source of the wind? And so if you look in Wikipedia or something, it'll say, well, a pressure gradient. But how do you imagine a pressure gradient forms to say to create a wind gust? So these are issues, that phenomena we see every day, but we don't understand them. And so this is my attempt to get there. But I don't want to deviate too far from.
Oh, it's great. It's great. These are all things I've wondered about as an observer, and participant and member of nature at large. I mean, it's just, if you pay attention, almost nothing makes sense. You know what I mean? I mean, I've like, sometimes I have these oak trees here on our property in Texas, and I look at those trees and I think, because my sprinklers have been down for a while because we were building a fence, so we had to have all the water turned off. And I think, how are they getting water, and how does the tree get the water from the depth of its roots all the way up to the very top of the tree, 50 feet up, and get water into those leaves, you know? And there may be a common answer for that, but that's the kind of thing that fuels my day as I sit here at my desk and look outside. I go, how the hell is the water getting up there? It's defying gravity. There's no pump inside the tree, for example, you know?
Of course, that's a good question that I do address in the fourth phase book and in other places. And we now actually have experiments. We're formulating a manuscript, and I think we have an answer. But the question is, you know, it's not just 50-foot tree. It could be a redwood tree of 300 feet.
Right.
And there are, as you know, there are tubes inside the tree. The tubes are called xylem, and they go from the roots all the way up to the leaves. And somehow you have to get the water all the way up. But if you think of a tube, or a cylindrical vessel that's 300 feet high, filled with water, you can imagine the pressure at the bottom. You know, 300 feet of water pressing down. It's enormous pressure. And yet the water somehow goes up. And there have been lots of speculations on it. But we found something that I think can explain it. We found that if we take a tube made of material that's hydrophilic, water-loving, and we immerse it in water, to our surprise, we found that water runs through like it would run through a straw. And if you turn it vertically, it still works. And we understand the mechanism, but in our interview so far, we haven't talked about the kind of water that we discovered, which is central to the mechanism. But we understand, based on these experimental observations, that there can be a system that effectively acts as a pump. And the energy that drives the pump is actually light. It's infrared light that comes from the environment. And the infrared light is absorbed by the tree, by your 50-foot tree. And the water is actually acting like a transducer, takes that energy and converts it into hydraulic force that actually drives the water up the tree. So there is an answer. I think we have the right answer.
That's so cool. And thank you for your patience on getting to the exclusion zone water. I think when I was prepping my manuscript for this, there's like, I really want to set this up because it's the crescendo of sorts is so fascinating to me. And I'm sure the listeners who are not yet familiar with your work, but I think the various phenomenon of how water behaves is just so vast and interesting, and it's a great setup. I'm hoping that most of the people listening are aware of how important it is to keep toxic cleaning products out of your home, something I've been working on for years. I found this difficult at times to master completely due to having to buy so many different products. Something funky inevitably makes its way under the sink as a result. That's why I was so grateful to find this company, Branch Basics. They make an all-in-one concentrate to replace all the other stuff I usually buy. You can use it to clean your kitchen countertops, floors, bathrooms and toilets, laundry, produce, and even as a hand soap. And the concentrate is super clean. It's fragrance-free, plant and mineral-based, free of harmful preservatives. It's biodegradable, gluten and tree nut-free, and not tested on animals. So this means it's free of endocrine disruptors as well. These are environmental toxins that mimic your natural hormones. They can affect the ovaries, adrenals, thyroid, and other glands, so it's best to avoid these. And no synthetic fragrances either, because they've been linked to asthma, allergies, skin irritation, metabolic syndrome, diabetes, obesity, cancer, and nervous system and respiratory problems. So you definitely want to avoid those too. Now, since Branch Basics uses a one concentrate formula here, one bottle of concentrate makes 3 all-purpose bottles, 3 streak-free bottles, 3 bathroom bottles, 3 foaming wash bottles, and does, get this, 64 loads of laundry. So when you run out, the only thing you need to repurchase is the concentrate and the oxygen boost. This saves you a grip of cash. You don't have to buy 20 different products. You buy this one and make a bunch of products out of it. All right, to get some, here's what you do. Go to links.branchbasics.com/Luke Story. And if you use the code Luke, you'll get 15% off all starter kits except the trial kit. Again, that's links.branchbasics.com/Luke Story. There was one question you mentioned, the spinning of the earth. And I was watching recently because I like to watch super far out documentaries about anything and everything that's unexplained. But it was like basically a documentary that was made by proponents of a flat earth concept. And they were dispelling all of the things regarded to the belief system around the earth being a sphere. And one of their main talking points was this fairly well-known fact that water always seeks its own level. So they're showing these large swaths of sea and lakes and various bodies of water and showing how the water is in fact a plane. And I thought that was really interesting because I thought, well, I've never been able to take any water and make it curve. So I mentioned that to a friend of mine because we were just discussing wacky stuff. And he said, yeah, water curves all the time. Water droplets are a sphere. I was like, oh, you got me. Okay. So water, I'm not, asking you to give your take on the shape of the earth, but is it possible, on that model of the earth being round that water curves around it? And if so, what the hell is holding it together and it's not just flying into space?
The simple answer is that gravitation holds it, and this is circumventing the question of the nature of gravitation, but gravitation holds it. If you're looking over a body of water, say a lake, and you look across and it's really clear, and you should be able to see the opposite shore, but if the distance is 3 or 4 miles, you can't see the people. Even with a telescope, because of this curvature. The curvature actually blocks out your linear vision. You can see only, if you're looking a few miles away, you can see only above a certain height. This is, I think, or might be taken as evidence that for the curvature. And of course, there's all the satellite images that you see, but it could be argued that these are all faked because there's so much that appears on the internet and other places that are faked, and it's possible to argue that. But another phenomenon that I always like to think of is if you take off from Austin, where you live, and go west, you land in San Francisco, and you take off from there and go to Tokyo, and then from there to Berlin, and from there to New York or DC, and then finally back to Austin again, and you get back to to where you started. So I guess there are 2 possible interpretations. One is that the Earth is round, and the other one is, okay, if the Earth is flat and you're able to get back to where you started, it must be like a cube. And I've been pretty conscientious. I like to look out the window when I fly, which is pretty often, and I could never identify the edge of that cube. Right. And so, therefore, right. I conclude that that those satellite images are telling the truth, and that really looks as though the Earth is a sphere, or is round. It's certainly not flat. Well, so that's my take on it. But
based on water, was my friend's assertion right that water does in fact curve? When you look at a droplet of water, it's a round sphere.
Absolutely, right? Yeah. And you can even see it. We took an example is we have a beaker of water, and you take a charged rod, a glass rod that's pre-charged, and you bring it closer and closer, and you see the surface lifting toward the rod. And the reason is electrostatic, because the charged rod is inducing opposite charge in the top of the water, and it moves toward the rod. So you can see a kind of rise in the water. That's a bit artificial, but you can certainly demonstrate it. And we've also found that the surface of the water tends to be different from the rest of the water. But I mean, frankly, I haven't been able to see any compelling evidence for the flatness of the Earth.
Got it.
I love alternative ideas and theories, but that one has not.
Yeah, well, it's funny, and I wish I remembered the name of the documentary. I mean, of course, with these type of films, the production value is exceedingly low, so you have to really be committed with some deep curiosity to get through it. But some of the experiments they did, in fact, were using high-powered telescopes over large bodies of water. I think they did one in Michigan, and they would zoom and zoom and zoom and show that you could see it perfectly without the interference of a curve, contrary to your prior statement. Who knows? It doesn't matter. This is the point was I want to find out from a water expert, does it curve? And it does. However, I would want to get now into the 4 principles of water that you identified. The first one being, and this is the kind of the meat of your work with exclusion zone water. The first principle being that water has 4 phases as opposed to the 3 that we've always assumed. So we know about ice, liquid, and vapor. And yet your work is largely focused around exclusion zone or EZ water. So let's go ahead and dive into that, because I have so many more questions about exclusion zone water in general and how it might benefit us to learn more about it and, learn how to integrate it into our lifestyles, et cetera.
Okay. It all starts, if I may, with a Chinese scientist who came to the U.S., whose name is Gilbert Ling. In 1948, he and 2 other young Chinese scientists were selected from throughout China to come to study in the U.S. So you can imagine the quality of the people who they chose. There was a physicist, a chemist, and a biologist. And Ling was a biologist. And the physicist went on to win a Nobel Prize, So these were top-level people. And I'm told that they all thought that Gilbert Ling, the guy I'm talking about, was actually the cleverest of all 3. And in retrospect, he passed a couple of years ago. I think he should have won a few Nobel Prizes for all of his contributions, but they were controversial. So he said the water in biology is different from ordinary water. He said he had evidence. He didn't just spout out. It was based on evidence that the water molecules were somehow ordered or aligned like soldiers at attention. Now, in liquid water, like the stuff that I should be drinking more of, the molecules are randomly disposed and they're bouncing around a fierce number of times per second or per femtosecond even. And he said, no, the evidence is that in biology, in the cells, the water is different. The molecules are actually lined up. And so you could think of a water molecule as a dipole, plus like a little bean with plus at one end and minus at the other end. And you can imagine these beans lined up like soldiers at attention. He said, this is what the water in biology or inside the cell looks like. And you can imagine this was not a popular point of view, but he had a good deal of evidence. And I met him at a conference in Hungary. And the conference was to commemorate the scientific life of a famous Hungarian scientist. And the scientist had 2 fields of interest. One was muscle contraction, and the other was water. And I'd been in the field of muscle contraction, so I was invited to present my ideas about how muscles contracted. And other people were invited to talk about water. And among those people invited was Gilbert Ling and an entourage of people who had evidence that was consistent with Ling's point of view. So I presented my stuff, And I started listening to Gilbert Ling, and I was completely intrigued by what he had to say, and even more intrigued by the people who had independent evidence to support his point of view that the water was different in biology, somehow different. And what I want to tell you is that what we finally wound up studying showed that Gilbert Ling was onto something really important, but it turns out to be, I think, a little different from what he exactly was espousing. The order, yes, but a different kind of order. Anyway, I came back from that conference really charged with energy, you might say, and I didn't trust myself because I can be naively attracted to certain ways of thinking. I'm susceptible to that. And so I gave one of his books. By that time, he had written 4 or 5 to my students, to some of the students in my lab. And the feedback was uniform. If this guy is right, it changes everything in biology. And it looks like he might be right. I was compelled that my students were able to conclude the same as I had tentatively concluded. And as I usually do, I want to do something about it. So what do I do? So the first thing I do is write a book. The reason for writing a book, the book was designed to present Ling's ideas to people who might not be experts. And the reason for doing that is Gilbert's writing is for some impenetrable. It's really difficult. And I knew Gilbert well enough to know he'd sit down at the word processor, and earlier not at the typewriter. He'd bat out something, send it to the publisher, and it gets published. And he lacked the sensitivity necessary, I think, to put his concepts into terms that are easily understandable. So I tried to do that. I tried to make his ideas understandable to the general public with maybe a smattering of background in science. And I'm not sure if I succeeded or didn't, but I went beyond that. The second half of the book adduces evidence to say that this kind of what Gilbert Ling called structured water, which we now call EZ, as you mentioned, or fourth phase water, that this was actually central in all of the major mechanisms that the cell undergoes. We found evidence, I, with the help of some of my students, that when muscle contracts, or when secretory cells secrete, or when nerve cells conduct, whatever the operation of a cell, it involves water. It involves a transition from this structured water that exists when the cell is quiescent, when it's not doing its thing, to ordinary liquid water when it is doing its thing, and then back again at the end. So when a muscle contracts, for example, before it contracts, the water is ordered in a way that's a little bit different from what Ling suggested, to ordinary liquid water, and then back again. And that was the second half of the book. And if you think about it, you mentioned that if you do a molecular count, that more than 99% of our molecules are water molecules, because they're 2/3 by volume, and to fill that volume, you need a lot of those minuscule water molecules. So if you do a molecular count, line up all the molecules, more than 99 out of 100 are going to be water molecules. And the books tell us that water molecules don't do much. They're sort of sitting as the background carrier of the more important molecules of life. It's like a bathtub. You sit in the bathtub and you're surrounded by the water. That's pretty much what the water does, according to the textbooks. And the textbooks still basically say that, which strikes me as arrogant. How could anybody imagine that 99% of the molecules in our body don't do anything? Well, the evidence is clearly against. The water molecules are central to so many processes that go on. Anyway, after writing the book, which got mixed reviews, some reviews said, "Oh, this is more nonsense. Just like Gilbert Ling, everything that comes out of Ling's mouth is nonsense. So pay no attention to it." To a well-known cell biologist from Harvard, who said, "This is a 305-page preface to the future of cell biology," which I liked better than
Yeah.
you know.
I'll take that endorsement.
Yeah, it's nice to, and so, well, after that, what do we do? Well, what we do is start experiments. Got to do experiments to find out, because this is so compellingly interesting about water and about the possibility that biological water is different from other water. Well, it turns out it's not just biological, it's all over the place. So we started experiments, and by serendipity, we found an experimental preparation that we could use. And by serendipity, the right people came to my laboratory to work, and everything just worked out beautifully. And so within a year or so, we had evidence that there was something different. There was a different kind of water. And okay, so what did we find? This long introduction. So the experiment, the main experiment that we did, and we're still doing it, is you take water and put some particles in the water, and then immerse inside the water some material. It could be a gel, it could be a polymer, but it had to be hydrophilic, that is water loving, the kind of surface where, if you drop water, it spreads out because the surface loves the water and wants to get as much of it as it can. So it loves it. So it's hydrophilic, water loving, as opposed to Teflon, where, you drop the water, it beads up. It had to be. So we put the material in the water and we looked in the microscope, and what we found astonished us. So we found that right next to the material or the gel, the microspheres, the particles in the water, began to get excluded. They were like pushed away from the surface, and they were pushed away by appreciable amounts, by maybe half up to half a millimeter. You could even see it with your naked eye. You didn't need the microscope to see it. And we knew that Gilbert Ling's ideas, we were prompted by his ideas, of course. In his ideas, the molecules were lined up. And if they're lined up, it's like a crystal. And crystals, as they form, if they're pure, they obviously have excluded all of the contaminants. So they push them out. Like you'd find, for example, in ice, in a glacial moraine, all the junk is at the bottom of the glacier, and the crystal of water, the ice, is clear, is pure. So that's what we were looking for, and we found it right away. So we did a lot of experiments, and I'll just summarize a few of the more important findings. One finding is that this region, every physical chemical measure of the water that's in this region, where all the particles, the microspheres, were excluded, everything we measured differed from ordinary water. So that's one thing. It had higher density. There was organization, clear, crystalline-like organization, high viscosity, and also electrical charge. So this region typically had negative charge, and the region beyond had positive charge. And you have to have both, because all of this is built from water molecules, which are neutral. So if you have a negative region, you got to have a positive region. This, in fact, if I might digress for just a second, this forms a battery. You have negative and positive that are separated. And we demonstrated that, indeed, you stick two electrodes in and you can get electrical energy out of it. Okay, so next thing we found that the structure of this is not the dipoles, the stacked dipoles that Ling was talking about, because dipoles are neutral. You can stack dipoles from here to the moon, and you'll never get negative charge. But the experimental results dictated that this region of exclusion bore negative charge. See, so couldn't be right. And we found that the structure was actually a hexagonal structure, a planar sheets that stacked. So if you, for example, if you have a gel here next to the water, the gel would nucleate the buildup of the first layer, and the first layer would then, the hexagonal layer, like a honeycomb pattern, and that layer would nucleate the growth of the next one from ordinary water, and then the next one, and so it would build sheet by sheet, and so not the same as what Gilbert had been suggesting, but the same theme, but different, and especially important was the fact that it was charged, had negative charge. So because we began seeing this feature again and again, because it excluded particles, a colleague from Australia, a physical chemist, said, you ought to give it a name. And he said, well, the obvious name is exclusion zone, because this zone excludes. It was actually, in retrospect, it was a poor choice. It had advantages and disadvantages. The disadvantage is that it doesn't really describe the central and important role beyond just exclusion, because there are so many other interesting properties. But anyway, the name kind of stuck, and later we also called it fourth phase water because it was different. And I guess the one maybe final property I should mention, this has energy. When you have a battery like configuration, it has potential energy, and that we found later that potential energy can drive many biological and non-biological processes. Is really important. But let me just first say the name, exclusion zone, EZ. It's easy to remember, but it doesn't work in other countries because the Z is a Z, so it's EZ to remember. But okay, because this has energy, you can't get something for nothing. You can't get energy out of nowhere. It's like your cell phone battery. It's got energy. It's got potential energy. It runs your cell phone, but if you don't recharge it, it's not going to work. And it's the same with the system. You have to recharge it. So where does the energy come from? And we were scratching our heads, our collective heads, for years, several years before a student found out where the energy comes from. And he was doing a simple experiment like the one I was just describing. And he took a lamp and he shined the lamp, and he called me in to show me that where the light was incident on the exclusion zone grew by leaps and bounds. And then he took it away and it returned. So it didn't take a rocket scientist to figure out that all of what I've told you is fueled by light energy. And we did experiments afterward. We found the particular wavelengths, and they actually lie in the infrared range, not in the visible range. So infrared light, which many would think about heat, it's not exactly the same as infrared, but close enough to think that this kind of energy it turns out it's all around us. So it's all over. If you were to turn off the lights in your studio, and someone would come in with an infrared camera, just like an ordinary camera, but with an infrared sensor instead of a visible light sensor, and try to get an image of you, even though you could see nothing, you get a beautiful image of you, the plants, the sofa, the walls, everything. Everything is generating infrared. So the energy that's necessary for the buildup of all that I've told you comes from our surround. It's always there, which means that if the circumstances are right, if you've got a hydrophilic surface next to water, you'll always have some easy water.
That's a really perfect explanation, and also a great setup for some of the further questions that I have specifically around easy water. The first one being a popular topic, I think, that's emerging to become even more so is structured or ordered water. So I've had people on the show talking about structured water and the idea that in nature, water is traveling in vortices and is thus structured. And then when we harness water for consumption and use, we put it into, a still vessel, or we run it through right angle piping in our homes, et cetera, and thus kind of ruin or spoil that water or make dead water, like thinking about Viktor Schauberger or Rudolf Steiner, both of whom you mentioned in your book briefly. So that kind of paradigm. But what I was curious was, is the common sort of understanding of structured water the same thing as easy water? In other words, if I use I have many structuring devices, this great thing called the analemma. It's a little crystal vial that you spin in water, and it has what's called a mother water in it that influences the rest of the water. Another thing called a natural action, little vortexer, and all kinds of toys like that. If one is structuring water in that context, are you creating or encouraging more easy water, or is easy water a different kind of structured water?
The word structured precedes our label of fourth phase or easy. Structured water, it's a general term. And I don't know if it was coined by Gilbert Ling or by others before him. And it's meant to imply that the liquid water is not just a collection of randomly oriented bouncing molecules, but it has order to it. It has structure to it. And the problem with that term, which has persisted for a long time, is everything has structure. So the term structure, what is it? It has no structure. Even if it's a random structure, it's a structure.
Right.
So I gave you a bit of the history of why we suggested the term easy water, which turns out to be not, it's convenient, it's natural. But I think fourth phase water best describes it because it's indeed a different phase of water. And now the second part of your question relates to water structuring devices, and put me back on track if I go off track, because I have a tendency to do that sometimes. First, with regard to vortices, a lot of people have, especially the great naturalist Viktor Schauberger, have talked about vortices creating living water, and living water is water that is endowed with energy. The problem with that is, while I think it could be true and probably is true, I've yet to see a really good experiment that demonstrates that if you have a vortex, the vortex builds easy or fourth phase water. We tried it ourselves in the lab, and I included something in the book, but it was, I think, not a convincing presentation. I think this needs desperately to be done because it's a simple expedient that anybody can use to put water in the vortex. And the problem is you have to examine the water during the time it's in the vortex. Possibly, it could be that if you establish a vortex, you're establishing or creating easy water. But after the vortex ceases, it may revert back to ordinary bulk water. Who knows? And so I guess the ideal way to do the experiment is to measure the water during the time it's being vortexed, but that's a challenge. Needs to be done. I would put it high on the list of. So we aren't really sure about vortex water, but if I had to bet, I'd bet that the result would be positive. Regarding devices, so there are many companies who talk about having devices that they produce that produce structured water of some kind, and some even call it fourth phase water or easy water. And I think it's obligatory for these companies who market their water to demonstrate that it's really what they've gotten. And many of them have not demonstrated, at least what I've seen. And so that raises a question whether it's really true or not true. And I could imagine it is true in many, if not most cases, but I think it's obligatory for people to be able to properly check out the water. In fact, the water is suggested to be good for health, and I think it would be good for health because your cells are full of easy water, fourth phase water, and if they're not full of that water, then they're dysfunctional in some way, and you may wind up with a muscle cramp or a headache or depression, or depending on where the water is deficient. So the water should be beneficial for health, and I think a lot of the people producing waters of some sort are aware of that fact, and they're aware of the usefulness of that water. I would put the burden on them to actually demonstrate, and it's quite possible that some of them have demonstrated. I haven't seen it, but this is I think important. Some years ago, I proposed to the National Institutes of Health that we study the beneficial effects of water on health, or the putatively beneficial effects of certain waters on health. And the response, and I'm paraphrasing, water? Whoever could imagine that water is important in cells and in life? It wasn't the exact response, but it was, so the NIH is eager and willing to spend hundreds of millions of dollars on testing the drug, some drug produced by a pharmaceutical company. But the idea of testing waters on different types of waters on health is something that so far I've seen no interest at all. It would need to be done by someone, a third party. We proposed ourselves at the time. We're on to other things at the moment, but we proposed that it not be a commercial entity. It'd be a neutral entity, an entity that has some experience dealing with water. And I suppose for something like $5 million or $10 million, clinical studies could be done. For example, taking some patients with stomach cancer, if you will, giving a group of water, a group one type of water, another dozen patients with a different kind of water, and so on. Experimenting by giving them any of a half dozen types of waters, and checking after a year or 2 years how did they fare. It's a straightforward experiment, but of course it's not simple to implement. It requires all kinds of controls and lots of people involved in doing the statistics and the experiments themselves. But it could turn out to be a critically important advance. It's necessary first to convince the folks at NIH that water is really important, and
convincing them of that when there's a conflict of interest between the pharmaceutical companies and the fact that the probability of patenting any type of water is very low, patenting water as a drug. So I think it's going to be up to citizen scientists and people like you to, bring attention to this. If you're like me, you probably tried a few, if not many, CBD products. And if it's done right, CBD can nourish the body's endocannabinoid system to support stress, sleep, and inflammation. The bummer is that most of the CBD I've tried either lacked a noticeable effect or contained undesirable extraction toxins and sometimes even pesticides. So I was ecstatic when I found this company called Ned. They produce USDA-certified organic CBD products that are chock full of premium full-spectrum CBD, including active cannabinoids, terpenes, flavonoids, and trichomes. So rather than trying to outsmart nature and isolate parts of the plants, they produce it as nature intended by capturing all the goodness in their Rocky Mountain grown hemp. I was also happy to discover that they not only created superior CBD oil blends, but also an excellent magnesium super blend called Mellow. And that one they combined magnesium, L-theanine, and GABA, and it's a beast of a sleep aid. In fact, I like to stack it with their CBD oil blend as a powerful sleep aid. So my daily Ned ritual usually consists of small oil doses throughout the day to keep my nervous system calm, followed by that combo I just mentioned at night to prepare for sleep. And let me tell you, this stuff knocks you out. When my anxiety is low and my sleep is deep, it enables me to not only have a greater sense of well-being, but also to be much more focused and productive. So these guys do it right with full production transparency, all available on their website. You can become the best version of yourself and get 15% off Ned products with the code Luke. All you do is go to helloned.com/Luke and enter the code Luke at checkout. That's HELLONED.com/Luke. Big thank you to Ned for sponsoring the show and offering our listeners a natural remedy for some of life's most common health issues. Back to the structured water and water that's beneficial to health, something comes to mind, and that is the longstanding folklore of healing waters around the world, from indigenous peoples soaking in natural hot springs that were purported to have healing and restorative benefits, to different cold springs around the planet where waters have been reported to be incredibly healing. And again, there aren't studies to prove it, but I've always found it fascinating that humans have migrated and settled around certain springs, both hot and cold, and actually built civilization around those springs. And it's not just because we know we need hydration. There seems to be something special about different waters that the earth produces or contains around the world. I'm curious if you've heard anything even anecdotally around people having positive outcomes with different natural waters from around the world.
Yeah, I have, and I think there's something to it. So a couple of examples. One example is the Hunza people somewhere in Asia, and it was, I forget his name, some Nobel laureate in fluid flow, who went to examine what was going on there, and he was able to conclude that there was something in the water that kept these civilizations, or that particular civilization, healthy. And the Hunza people are known to sire babies at age 100 and live long, productive, and healthy lives. So the water seemed to have a real impact. Those studies are known and published. And then there's another one that has impressed me. A friend of mine who's interested in water came upon a spring in Idaho, and it's southeastern Idaho. And the story of this is it's owned by Native Americans, or it had been owned by Native Americans. And the story is that when a chief, had to be a chief, became ill, the chief would migrate from wherever around the country to this special spring in Idaho and stay there and live there for a period of time and drink the water. And the water was said to have certain healing qualities. And it became really well known. And it was reserved for chiefs only, and not for the peons, so to speak. And my friend is trying to do something commercially to bring that to fruition because of the history that comes with it and the apparent efficacy, which he's now studying. So wow. This is one example, which may turn out to be a really fruitful example. There are lots of challenges associated with actually taking the water itself and converting it into, or bottling it, or however producing it to making it available to people. It's not a simple thing to do. So those are a couple of examples that I've heard about, know a little about. And there are others. And when I try to, shall we put it, remain independent of any particular product, because I treasure my reputation as a scientist. I don't want to be touting the efficacy of a company's particular kind of water.
Yeah, yeah.
You understand. But
Yeah, totally. I think that's why I enjoy doing what I do, because I'm not beholden to scientific rigor. It's just, N equals one experimentation and trying to find the best of the best out there. And water is something, as I said, that I've spent a lot of time researching and exploring and also sharing with people. To that end, in terms of some sort of evidence as to the different qualities of water, I think you're familiar with a recent former guest, Veda Austin, who photographs water, as well as Dr. Emoto from Japan, who was I'm sure, as you know, a pretty famous guy in the realm of water, and both of them using different techniques to photograph water and actually showing pretty unequivocally, I would say, that our intention, consciousness, energy, call it what you will, has an impact on water to the point where it appears, especially in the work of Veda Austin, to have an intelligence. And you've talked about some early scientists purporting that water, contains memory and such in the case of homeopathy, et cetera, being debunked. But now it seems that more people are becoming curious and doing some of this experimentation, showing that water does, in fact, have very unique properties depending on the stimuli to which it's exposed. So I wonder what your take is on the various water photography and what that might mean for us moving forward.
I know Veda Austin pretty well, and I know the Emoto people, although unfortunately, Masaru Emoto, I had invited to our water conference several times, and he was ill. And finally, invited him to my home because he was coming to the Pacific Northwest, and he accepted. But unfortunately, he passed a few weeks before, and so I never got to meet him in person. Although we shared the platform on an interview. But I know all the people, pretty much all the people who worked in so-called office Emoto in Japan, and starting with Emoto, who was obviously the pioneer in that sort of thing. And for your viewers who don't, or listeners who don't know about Emoto, he was a spiritualist. He wasn't a scientist, and he would put he'd have some petri dishes filled with water, and he put his intention toward the water. He'd think about peace or think about love, and then he'd freeze the water and he'd look at the water crystals, and he'd also subject them to feelings of I hate you, or something equivalent, you fool, or something like this, and they'd freeze and look. And the water crystals were ugly. And he'd also play music. And if the music was John Lennon, Imagine, or a Mozart symphony, or Bach, he'd get beautiful crystals. If it was heavy metal, he'd get ugly crystals. But there was one problem. And the problem was explained to me by his former translator, who was always on the spot to answer questions. And he told me that when Emoto would present to a group, inevitably the questions would arise. How did you choose your data? And the truth was that among the 50 or so petri dishes, that he'd picked the one that showed best showed what he wanted to show. And this poor guy, the translator, was on the spot to justify his approach. And he told me it became awkward, and eventually he, after some years, he finally quit. But his response was, "Well, I'm not a scientist. I'm a spiritualist." And so, as a spiritualist, he felt that he was justified in doing it his way, in choosing the one that best illustrated what he wanted to illustrate. Well, that among scientists, that's arguable whether that's a reasonable approach. But I've been well connected not only to the Emoto people, but also to Veda Austin and to some others who are doing it, trying to encourage them to check the repeatability of what they're doing. And Veda is doing that. right now, and some other people are beginning to do it. And I'm astonished by what I've heard about the repeatability. It is repeatable. Some images. So Veda was actually at my home one day, and she wanted to illustrate. She said, "Think about some image," and I thought about a house. Okay, and focused my attention on it. And then she took the petri dish with water, which was sitting in front of me. She put it in the freezer for only 10 minutes. And she took it out, and it was a thin layer of ice on top. And sure enough, I could see the slope roof. And that was, of course, n equals 1. But it was representative. So those experiments, I think, are going to demonstrate, they're in the process, that there's something going on there that seems to be repeatable. And if it's repeatable, it's likely to be real. But it's not just those people. So the field attracted, after Jacques Benveniste, it attracted multiple people who demonstrate year after year at our annual conference. That's going to take place in October in Germany. Evidence for different approaches, but also that demonstrate water memory. And I guess the most prominent of people is a guy named Luc Montagnier, who won a Nobel Prize. He had been friends with Jacques Benveniste, and when Benveniste died, he took over and he decided to shift the emphasis of his research from virology to water and water information and water memory. So it's interesting that, so distinguished a scientist was attracted. And he came to our conference each year and presented his work. And one of the experiments that he did is, if true, and it seems to be true because it's been repeated and published by several groups confirming it, he was able to prove that the information from DNA could be transmitted not chemically, but through some kind of subtle energy that is yet to be defined to water, and held in the water. So his experiment consisted of, he took DNA in water or in a buffer and sitting next to water, and the two were completely sealed. No possibility of any chemical communication. And he added some generic energy, 60 hertz, 50 hertz. The DNA was a short strand of any of a number of different kinds of DNA. And he would dilute it and dilute it and dilute it, eventually diluting it to homeopathically to the point that it was essentially just water that had been exposed to the DNA. But prior to that, only modest dilutions, but the result was the same. So after 24 hours, he took this, threw it away, and he'd have water. He said, this water is now informed with information from the DNA or from the water that surrounded the DNA. And to prove his point, he took this water and used it in the PCR test, the same as now is used so commonly for COVID. And the DNA that came out of it had the same sequence as the DNA that was sitting here in this container. So proving that there's some kind of subtle information coming from here to the water. Otherwise, you wouldn't have gotten that result. And as I said, it's been confirmed. So what I mean to say that it's not just Emoto, a spiritualist, and other people, but multiple scientists who have all kinds of different approaches and different pieces of evidence that water can store information, including all the way up to Nobel Prize winner. And another one, Brian Josephson, another Nobel Prize winner, who hasn't done experiments of this sort himself, but is espousing the theory. So it's morphed into a weird observation by some spiritualist to what is soon, I think, becoming a very interesting frontier area in science.
Wow, that's exciting. What a trip with the DNA experiment. That is, that's just far out. That's what I love, being a human on Earth for reasons like that. It's just fascinating. There's so many things we just don't understand. And the things that I think, for me, the things that can't be explained are the most interesting. Once something's explained, it's kind of like, oh, okay, well, now we know how that works. What else is there to it, right? But it's the mystery. When it comes to the fourth phase water and its relationship to infrared light, and knowing that our cells benefit so much from having this type of water in and around them, would infrared saunas, red light therapy, sunbathing, cold immersion, ice baths, cryotherapy, where we're using, I guess in that case, the infrared heat within our body, I would assume is going to move that fourth phase water around our capillaries and veins. Is there any evidence, or do you believe that things like hot and cold therapy, light therapy, and things like that will help us to produce more of this fourth phase water within our bodies or utilize it more effectively?
I absolutely think so. I think you've hit on a really important point. Let me first address hot and cold, because before I forget, because it's really important. Reflexive response. Well, if infrared or heat really helps, then cold should do the opposite. But in fact, it looks as though cold does the same. And I think the reason is, first of all, we established that infrared light grows the EZ like crazy. Very modest amounts of infrared light can bring about 10 times growth in the amount of EZ water. So it's really powerful, and it follows that if EZ water ordinarily fills our cells and we expose those cells to infrared light, it should build EZ, and if EZ is central to function, it should improve function. At the same time, Wim Hof and others have shown that if you immerse yourself into cold, you also get a beneficial effect. And why is that? When I think you're right. It's the metabolic energy that's produced inside our body that produces heat. It produces infrared energy, and ordinarily we know that infrared energy, like for example at night when the Earth cools off, the infrared energy is being radiated from the Earth out into the cold environment out there. Somehow it gets there. How it gets there is, I think, not so well understood. But the infrared radiates from warmth to cold, and then you think about your body, and you've got a core, a metabolic core of infrared energy, and it radiates outside the body to the area beyond. And in so doing, it passes through all the tissues. And in passing through the tissues, it pretty much, you might surmise, it does pretty much what the infrared energy does that's coming in from the outside. So it doesn't matter. It's bidirectional. It could come in or it could go out. It passes through the tissues. And as it passes through the tissues, it builds EZ water. And if EZ water is important for health, which we believe from all the evidence that we've gathered, it's absolutely important for health, then it's going to work. So that is critically important. And there have been some approaches to light therapy. There are many groups studying light therapy, and red light is included. And I've run into clinicians. I don't know if the work is published because I don't have time to follow all publications. But I was impressed by one guy I met when I was giving a talk in Germany. He's a physician. He approaches me. He said, "I use infrared light therapy and it works brilliantly. I deal with cancer," he said. And sometimes women, particularly, will approach me and they have some cancer that is grown somewhere on their face and they don't want surgery because it's disfiguring. And so they come to me and I apply infrared and the cancer goes away right away. It's so quick and so obvious. And, I'm wondering and thinking, well, by applying infrared energy, it's returning the cells that are dysfunctional to cells that return to function. And I could imagine that it's simply a matter of building easy water, which then converts those cells back into normally functioning cells. So light therapy is important. It's used. It's becoming more and more important. And some of the people are using infrared. I think a lot of it is anecdotal. My colleague tells me there are some published papers on it. I think it's important, and I think it's going to become increasingly important for the use of infrared therapy. And you've had the experience yourself in Austin. I'm not sure how many saunas exist.
I've got 3 here at the house.
Oh, okay, yeah.
Which is probably funny to some people that live here, because I think it's 104 degrees here today, and people are probably thinking, why on earth do you need a sauna? But I also like to get in the sun a lot. But the relationship between the easy water and sauna therapy, red light therapy, is really interesting to me, because I just know that, like, for example, I started my day today. I stood on a vibration plate in front of my Juve red light, which has near, mid, and far infrared. For about 10 minutes, felt great, got all my circulation, lymphatics moving. And then I took a sauna in this thing called the Sauna Space, which is a near-infrared incandescent light bulb sauna, essentially a little tent. Actually, no, first I did the Juve red light, then I jumped in the ice bath, then I went into the near-infrared sauna, and then I went back in the ice bath. And I'm telling you, man, there is nothing that I've found, and maybe takes an hour to do all this, but there's nothing I've found that makes me feel reliably as good as that routine. Hot, cold, hot, cold. Especially if I do it a number of times. I mean, today I just got cold, hot, then cold, but if I go to a hot springs and there's cold water there, I'll do that for hours, and I feel like I'm just elated afterward. And not only just the mood regulation of it, but the energy production. Like, I just feel so much more energy after that. When one would think you would be depleted from being hot and cold over and over again, I find the more I do it, and with the more regularity with which I do it, I just have increasing metabolic energy. So there's got to be a connection there with the water. So I'm really pleased to hear that you think there might be as well. I'm going to take a moment to ask you something. How often do you wake up in the morning and instantly wish you had just one more hour of sleep? You hit the snooze button and hope next time your alarm goes off, you feel more energized. Well, I get messages from people all the time specifically asking for brain solutions. So they usually mention things like brain fog, low energy, poor focus, and so on. Well, I recently found a truly incredible solution to all of this called Nootopia. They specialize in personalized brain supplements known as nootropics. Taking this stuff is like flicking a switch and turning your brain on within the first 10 minutes of waking up in the morning and feeling totally engaged, focused, upbeat, and productive no matter what life throws at you. I actually had my dose of Nootopia this morning, and I'm feeling quite focused and perky. And I've experienced this effect over the past few months since trying Nootopia. These guys have legit created the most advanced brain support and cognitive enhancement system that I've ever tried, and I've tried a lot of them. It's kind of like a do not disturb feature for your brain. And unlike other products in this category, there are no crashes, jitters, or side effects. I'm actually shocked that these formulas work so well without making me feel uptight and tweaked out, which is often the case with things that can be stimulating to the brain. So I highly recommend the Nootopia system for anybody looking to take their focus, creativity, and mood to a new level. So to turn your brain on, go to nootopia.com/Luke and enter the coupon code Luke10 for an extra 10% off. That's NOOTOPIA. These guys are so confident that their stuff works. They also stand by their products with a 365-day money-back guarantee. So this is a no-brainer for your brain. Again, that's nootopia.com/Luke, and the coupon code is Luke10 for an extra 10% off. On to more of the fourth phase water. I have a device here by a company called Eng3 called the Nano V. I'm not sure if you're familiar with it.
I have one.
Oh, okay. In this little vessel here on top, there's distilled water. And somehow these guys have figured out how to make fourth phase water in a fine vapor that you breathe. And this water then goes into your system and gets into your cells, which I think is just, it's got to be one of the coolest inventions ever. And it, again, like the therapies I mentioned earlier, it makes me feel amazing, which is why I have it here on my desk. I just sit here and breathe it in as I work a couple times a day. And I've been doing that for years. And they, I think, have a decent body of research and evidence to prove its efficacy. But I'm really looking forward to more of these type of developments where people start to learn about this phase of water and actually use their creativity and ingenuity to bring more accessibility to people. Now, this device is pretty pricey. It's, I think typically used in a holistic healing clinics and things like that. But many people I know have them, and they've saved their money and found the value in it. What's your take on this? You said you have one. What's your take on this particular technology? Do you see anything else like this emerging that could be useful in this way?
Well, I think a lot of things can be emerging, and as I said, I don't like to tout any.
Oh yeah, that's true.
This comes from Seattle, but I just want to talk about the principle. So what he's doing is he's infusing light into. Well, first of all, little droplets of water. So what do little droplets of water consist of? Well, we found, and this is in the fourth phase book that you mentioned, which, by the way, has become really popular, and it's translated now into about 10 languages.
Awesome.
But yeah, I'm pleased. It's mainly because of my son's artwork, not any particular gift on my part, but whatever. So what's a droplet? And I treat that in the book, and we found, based on experimental evidence, that a droplet is typically spherical or almost spherical, and what keeps it into this spherical shape, and we found that it consists of easy layers. I mentioned that the easy was planar, but of course a plane can be wrapped around, and so we found that a droplet consists of multiple. The envelope consists of multiple sheet-like layers that exist. It's like onion skin or onion layers, and then inside that is ordinary liquid water inside a droplet with protons, and the protons are repelling each other. Therefore, they push out, but they push against this resistance of this easy layer, and because of the pushing out, it's like a balloon. And that's why it retains a spherical or almost spherical shape. So by putting light in, the light is then being absorbed by these easy layers, and easy layers grow and they have potential energy. And I think it might be that the efficacy of the device, it comes from the potential energy that every droplet that every aerosol droplet that you breathe in contains energy. You get that energy, you get easy, and therefore, you're feeling better, you're feeling healthier. I think that's the mechanism. As far as I know, it appears uniquely in that particular device.
Yeah, I want you to remain a trusted scientist and researcher, so I'm very pleased to support you in your non-biased opinion. For those listening, I want to let you know you can find the show notes for this episode at lukestory.com/ezwater. I'm sure we've talked about a lot of historical references and things like the nano-V that people are going to want to research. So if light is affecting water in the ways in which you've discovered and we've described here today, could conceivably one expose their water directly to red light without having, the nano-V? Because what's going on inside the nano-V, I don't know, because it's, an enclosed, really German-made, metal machine. But it does have a setting where you can actually adjust the light that is the ambient light coming out of the little glass jar. And I have it set to red again because I don't want blue light at night. But I have from time to time experimented with my drinking water and shined a a red light on it for a period of time while it's going through the vortexer and things like that. And it's just kind of a fun experiment. And there's no way that I could ever prove that it's doing anything. But do you think it's conceivable that directly exposing one's drinking water to red light, almost giving that water red light therapy, could have a positive effect or increase the likelihood or the amount of easy water present?
It's possible, but it needs to be tested. So if the water, for example, contains some minerals, if the water is in a container that can nucleate the growth of EZ, and any of those could be the source of EZ water. And once you have EZ water, if you put light in, especially infrared light, you're going to get a growth of EZ water. So in theory, it might work. And I should mention that in India, there's a woman who works in my laboratory, comes from India, and she told me about her grandfather who followed the tradition that's followed by a lot of people in India, where you put water into a jug that's colored, and one is colored green, one is colored red, and I don't remember, maybe blue. I can't recall. And you put it in the sun, so it absorbs the sunlight. And depending on what your issue is, whether it's the flu or pain in the back or whatever, you drink from one or another of those jugs. So it's in history, probably dating back to Ayurvedic times, 5,000, 10,000 years ago. And we have a tendency, unfortunately, to discount any of those traditions as being non-scientific. This is gradually changing because we've come to realize that there's a lot of wisdom with those ancients. So it's possible. The answer to your question, I don't know whether it does or it doesn't, but it's something that needs to be studied.
Okay, good. Well, I'm hoping someone listening who's got a laboratory will get on this. Another thing that I've done periodically is, to your point about the Ayurvedic practices in India, is put my water in a Myron glass vessel, which is kind of a purple glass. And I forget if it cuts out the UV or the infrared or what the case is, but it's widely known amongst hippie types like me, or at least believed by us, that you can structure the water by putting it out in the sun in that particular glass in particular. So that's interesting because I didn't know about the correlation to that historical reference. That's interesting.
Well, yeah, I mean, it's possible. And in certain cultures, like the Korean culture, there are certain crystals that are heated, and you could sit in a room surrounded by those heated crystals, different ones for different issues. And so it's sort of reminiscent of what you're talking about. And, there may be a lot to it. I only wish that more people would be studying this, and but it's really hard, and it's hard to get money for studying this because I pointed, for example, to the NIH. There's a wall around the NIH where water can't penetrate, or a lot of stuff can't penetrate, and we are ourselves in our laboratory. We had been fortunate to be funded. It's hard to get money from the government to do this, but a private funder came across our work, and for now, I think 7 or 8 years, has been very generously funding us. Unfortunately, he ran into some financial difficulty, and he's had to withdraw. So our operation is now zero funding, and unless we're able to find some replacement funding, it would represent a closure of our laboratory and all that we're doing.
Oh man, dude, we can't let that happen.
Well, I mean, if any of your listeners, are interested in this stuff, please, I'm easily reachable from the internet or whatever, ghp@uw.edu. It's very easy. And we would appreciate anything because it could be imminent disaster.
Well, I'm hoping that out of the 10,000s of people that are going to eventually hear this in the coming months, that someone will be motivated to support you guys. And as I said, we'll put all of the links to everything discussed, including your upcoming event, because this will have published by that time. We'll put all of those links at lukestory.com/easywater. I've got one more technical question for you, and then I'll let you off the hook here. And I appreciate your generosity of time. It's a long time to sit in front of a computer for all of us. I'm curious about metabolic water or deuterium depleted water that your body manufactures, if I'm not mistaken, within the mitochondria. Is that synonymous with exclusion zone water, or are we talking about two different things?
I know there is abundant evidence that if you drink deuterium depleted water, it's good for health. I've seen studies, and it seems that the studies are reliable. I've heard it from different quarters. And my hypothesis is pure speculation because we've done nothing. It could be, since easy water is like a crystal, and crystals are built of the same entities which repeat again and again and again. And so if you have a different entity, like, for example, a water that contains some deuterium molecules, they may not fit in the lattice as well. And therefore, the buildup of easy water in the face of those deuterium molecules may not be able to build as readily as if you remove them. Then you have a pure crystal. The pure crystal can grow better. So this is a pure speculation. I have no evidence to support that, but that's where if we began studying it, and we actually initiated some studies, but so far they haven't progressed very far. That would be my speculation.
Okay, that's interesting. Yeah, over the past few years, I have done a few rounds where I've exclusively used deuterium depleted water, anywhere from 10 to 95 parts per million, which is much lower than any water you'd find in nature typically. And interestingly, aside from just anecdotally feeling more energy, just to state it basically, I have tested my deuterium levels periodically throughout. And each time I've done a cycle of that water for 2 or 3 months, my levels have gone down dramatically in a way that they would never be able to just live in my life. So I think that's very interesting. And I've interviewed a number of experts who've focused on the deuterium depletion thing. And I think one of the interesting things about it that might meet your speculation is that when this heavy hydrogen, deuterium, gets in the nanomotors of the mitochondria, it essentially gums them up and slows them down and makes it more difficult for them to produce ATP, which kind of goes along with that, what you just stated about the crystalline structure of the water being able to then make the easy water within your body. That's really interesting.
Well, I mean, it's one speculation. There may be others, but
I respect that. I mean, I'm just putting the pieces together and going, oh, interesting.
You're great at putting the pieces together.
Thank you. One, I'm an armchair scientist here. I mean, what I'm looking for myself and also the audience is just any and every way that one can expand not only their vitality physically, but ultimately really their consciousness, our consciousness. The more we can get in touch with our curiosity and our passion and intuition and those things that keep life interesting and mystical, that's what this show's all about. And you've done a great service to us bringing your body of knowledge. So I thank you for coming on the show today.
It's my pleasure.
Yeah, I mean, I could geek out on this stuff forever, as you may have guessed at the 2-hour mark. I do have one final question, which I ask all of our guests, except the one time I forgot. You've taught us so much here today. So I want to ask you 3 influences in your life, 3 teachers or teachings that have really impacted your worldview or your scientific endeavors that you might share with us.
The first one was the Japanese guy who I mentioned, who taught me that theories put forth even by the most distinguished of all people could be flat out wrong. That's the first really important one. The second was meeting Gilbert Ling. I talked about him and demonstrating to me that there was something different about water. And the last one is maybe my great scientific hero, and that is Albert St. Georgi. And a lot of people don't know him. He's considered to be Hungarian scientist, the father of modern biochemistry. He won the Nobel Prize, of course, for his studies, his discovery of vitamin C. But he was more than that. He was a scientist's scientist, and he knew so many things about creativity and approaching a science in the way that could reveal really genuinely new concepts. And he's famous for various aphorisms, one-liners that. So, for example, among my favorites, life. He knew about structured water. He said, "Life is water dancing to the tune of solids." That's one of them, popular. The one I like the best is discovery. He said, "Discovery is seeing what everybody else has seen, but thinking what nobody else has thought."
Wow, that's amazing. Precious? I love that.
Yeah. So I love that. So those you might say are the three people who influenced me maybe the most. With more time, I might think of some more, but you asked for three.
Oh, that's good. Three is good, man. That's adequate. Well, thank you so much again for your time today. It's been really fun to finally get to meet the man behind this incredible book and your body of knowledge. So I very much appreciate you joining us today. And we're going to, as I said, put in the show notes, links to your lab and organization and your event. And, I encourage everyone listening to get on board and to help you further your research because it's really important.
Well, thank you. I really much appreciate that. It feels important to me too. And I would like to be able to continue.
Well, man, if you're still this passionate at 82, you must be onto something. We can't stop now. If you're not ready to stop, then we should find a way to help you continue.
No, I'm not ready to stop. No.
Right on.
Okay. Luke,
right on.
Yeah. All right. Thank you. Thank you so much.
Well, that was a hell of a lot of fun. I trust that you're leaving this conversation with a new or perhaps renewed interest in the mysteries of water. And you can count on me for more shows to follow as I continue my research with this fascinating and, as you now know, very understudied substance. And I want to remind you that you can find the show notes for this episode at lukestory.com/ezwater, where you will also find links to Jerry's work and ways in which you can support what he's doing. As you heard at the end there, they lost their main source of funding, so they're looking for some support, and I would love to see he and his team be able to continue their research. It's really important work, as you now know, having taken in this episode. And speaking of episodes, we've got another one for you next week. It's number 426. It's called This Is Your Brain on Nootropics. Supercharged focus, creativity, and energy with the fascinating character that goes by the name Dr. Newts. Tell you what, if you're one of those listeners that's been asking questions on social media and in the Facebook group and so on about getting your brain optimized, next week's show is going to do it for you. It's hardcore. Before we split, let's take a moment to thank our sponsors, because honestly, this thing wouldn't be happening if it wasn't for them. We've got InsideTracker.com/Luke, where you can get some biometrics on what's going on in your body and some lifestyle design advice based on what you find. Then we've got links.branchbasics.com/LukeStory, where you can get some super green, super clean home cleaning products. We've got helloned.com/Luke for some awesome CBD. These guys really do it right. I'm a huge fan of the Ned CBD. There's a lot of swag out there. It's hard to come by good CBD. Those guys did it. And then we've got our newest sponsor, Nootropia. So if you want to turn your brain on, those guys are going to do it for you. All right, that's it for me. I'm out of here. I got to record some more episodes. I'll be back next week with number 426.